Hey everyone, we're going to do some notes on page 15 today, and we're going to be talking about density. That's the main thing. A bunch of other stuff, but the main thing is density. So to start with, we need to set up our page for Cornell notes. So I'm going to draw a line straight down, and then two across paper, and then one down here. So remember, in the top right, you put your name. I'm going to put mine, Mr. Will, and it will be okay. And so then we're going to talk about density, the main part. So let's put density up on top. And the essential question that we're going to talk about today is, what can we measure? And there's obviously a ton of things we can measure, and a lot of them are even based on other things that we could kind of build up off of. It's really very, very interesting. So, first one we're going to do is length. Now, to find the length of something, it's pretty straightforward. It is typically the shortest distance between 2 points. So we're just going to write distance from one point to another. And we're going to be using meters for that. Okay, not too difficult. To actually measure something, we're going to practice this a little bit more, but typically you find the first big number and then you find the little dashes after that. The first big number is going to be our whole centimeters typically, and then the one after that is usually after the decimal. And so in this case we have 4, and then we look over and it's 7 dashes, little dashes over, and that gives us 4.7, and then we put our label on it, which is centimeters. So we're going to be working on that a little bit as well. Our next thing is volume, and there are two ways that we're going to find volume. So volume is the amount of space an object occupies, or how much space something takes up. And for that, we will use a liter. Now, when we think of liters, sometimes we think of pop bottles because you can get a liter of pop. I thought this was kind of a cool demonstration, or image, I guess, not demonstration, but it shows how many sugar cubes are in a can of Coke versus a bottle versus, I think that's a half liter, or a 1 liter versus a 2 liter. But each of those little sugar cubes is 1 centimeter by 1 centimeter by 1 centimeter, so 1 cubic centimeter. And that's actually also a milliliter, like how much space that would take up. So it's kind of interesting. So we're going to find this in two different ways. The first one is let's do found, doing length times width times height. I don't know why I didn't capitalize the H there, sorry. So in that case, we would have a box almost, yeah, right? Let's finish that. So then we would have length, width, and height. So you guys can try and draw a box if you want. See how you do. I think you actually get to do that in art this year too. So what we found in my room, the length times width, that was the area. So we got the bottom two, and then we just add height. And then multiply all those together, and we get our volume. But there is another way to find the volume. And it's got a kind of interesting story, I think anyway. But let's say we have this odd object. So for example, if I have a rock, or in this case, this oddly shaped piece of wood, and I want to find the volume of it. Well, I can't just do length times width times height. That's not going to give me an accurate number. What I need is something that'll tell me how much space it occupies. And I can actually use water for that, which is really cool, because if I take this odd shape and I put it in water, however much water it pushes out of the way or makes rise up is how much space it takes up. And so if I have a measuring tool for that, which we do, it can tell me how much volume it is. So, in other words, we can use a graduated cylinder. So I'm going to write that. Did I spell that wrong? No, I don't think so. Graduated cylinder. And it might be helpful to draw a picture of that as well. And it's got little notches on it. Yeah, that's pretty good. All right, usually it has a base, and sometimes it's got a little spout thing, whatever. So graduated cylinder. So that's going to tell us using water. So I'm going to put so that's kind of cool. And another fact for volume is that 1 milliliter is equal to 1 cubic centimeter. They are interchangeable. So if I measured 1 centimeter by 1 centimeter by 1 centimeter, this space right here is equal to 1 milliliter over here, which is kind of cool. So anyway, the story behind this is with, shoot, was it Archimedes? No. What is it? The one that said Eureka. That's going to bother me. Whatever. He put the crown in the water to see how much space it took up, and then measured how heavy it was and tried to match it to the amount of gold that the king gave to the goldsmith. And it was a really cool story. I'll probably post a video or something with a link to someone talking about it. It's good. Now, let's move on to mass, matter, and weight, because with these things, we can do density. So, mass. Mass is how much stuff or matter is in an object. So, amount of matter or stuff in an object. So, you have a mass, but you also have a weight. We'll get to that in a second. So there's mass. Then we have matter. And this is anything that has mass and takes up space. Anything that has mass and takes up space. So, my pen, for example, my paper, they both have mass and they take up space. I could measure both of them. There are some things that we can't. Some people said air. Air actually does have a mass, and it takes up a certain amount of space. It's just really like it doesn't have a lot of mass. So there are some things that aren't matter because they don't have mass, and light is an example, or just energy, electricity, for example. And then weight. Some people interchange weight and mass, and that is incorrect, because if I go to the moon, I have the same amount of mass as I do on Earth, but my weight is different because weight is dependent on gravity. So weight is the force, it's an E, of gravity on an object. Okay, so we have mass, matter, and weight. So again, if I have a mass of 100 kilograms on Earth, I still have 100 kilograms of mass on the moon, but I have about 1/8, I believe, the amount of weight, because there's 1/8 the amount of gravity on the moon, which is kind of cool. So we're going to measure our mass with a balance or a scale. And, oh shoot, I forgot to put, it's measured in grams or kilograms. Yeah. All right, and then finally we get to density. Density is the ratio of mass per how big it is, the volume. So let's just put that. Mass per unit volume. What this means per unit. So for every 1 unit of volume, so if we go up here, a unit of volume would be like 1 milliliter, or 1 liter, or 1 cubic centimeter. So that's our unit volume, just one of them. So however much I get of this per one of those is my density. You can look at it like miles per hour. This many miles per 1 hour, like per unit time. So that'd be hour. So anyway, so we would need to find our mass and how big it is, and then just divide the two. So we would just write mass divided by volume. Should I just go like this? Equals. Okay. And then we have our example, 5 grams per milliliter. So this would be my label, grams/milliliter. We'll be using that quite a bit. So in order to find the density, we need the mass and the volume. And so we would find those, for one, the mass, I would find using the balance, and I would find the volume using either a graduated cylinder, if it's a weird shape, or I could just use a ruler and find the length times width times height. So that's the basic question that density is answering. How much does it weigh, or how much mass does it have? And based on how big it is. So one of the benchmarks we use for density is actually water. And water is equal to 1 gram per milliliter. And so if an object, so let's say I have an object over here, let's say it's a bowling ball. Can I draw a bowling ball? It's a weird bowling ball, whatever. Let's say it's 2,000 grams and it takes up 1,000 milliliters. That would equal 2 grams per milliliter. And so this is much more dense than water, so that would mean it would sink. Raise that up a little bit. Okay, but if I have another bowling ball over here, it's not a great bowling ball, but it's okay. And let's say it's only 500 grams, not realistic, but still, and it's still 1,000 milliliters. That would equal 0.5 grams per milliliter, because I divided 500 divided by 1,000. It's 0.5, and that would mean it would float. What would happen if it was the exact same as water? If it was 1? We're actually going to find that out in one of our labs, but it's a good question. So this is actually it for our notes. We have the whole list of, well, this is not comprehensive. It doesn't include everything, but our basic things that we are going to be measuring. We're going to measure the length, which is going to give us our volume. Our volume is going to allow us to calculate density once we measure mass. And in order to have mass, we need matter, which is, stuff, which is this part. And then we're going to do some calculations and stuff down here. So this is kind of the fun part where we actually get to do the experiments in the labs and stuff, and measure and compare. So this is what we'll be doing once we get back. We'll get to do some of these labs. Until then, there is a simulation where we get to find density and calculate it, and that's actually kind of cool too. So go ahead and copy all this down if you haven't already as you're following along, and this will be your page 15. Bye.